let's continue with stratified sampling method. So sampling with different subgroups and some information about population must be known for stratification, which means that we need to divide the population into different subgroups first. Okay, they're called strata, and randomly sample individuals in each strata and combine sampled individuals from each strata to establish a big sample. Okay, in this big sample, all those observations, they are from different strata, and there could be proportional or disproportional stratified sampling, depending on whether the sample size of each strata matches the population size of each strata or not. Okay, so n equals 50 individuals. So one strata could be 20, another one could be 30, right? And advantages of stratified sampling includes more precise if variable associated with strata. For example, in remote sensing, sometimes we need to sample some pixels from an imagery, and there are urbanized areas and rural areas within this specific image. So if I simply use a simple random method to sample pixels, because as we all know that rural areas, they are larger than urbanized areas. If I use simple random methods, most sampled pixels are expected to belong to rural areas because rural areas are larger than urban areas. So it's more likely that a pixel from the rural area will be sampled. So if that was the case, the urban areas, they are underrepresented because there are less pixels from urban areas sampled. So usually we do stratified sampling for that scenario. We make sure that there are two strata. One is rural areas. Another one is for urban areas. And I ask the computer to sample 50% of total pixels from rural areas and 50% of sampled pixels from urban areas. So this stratified sampling method will make sure that rural areas and urban areas, they are equally represented by these sampled pixels, right? So that's a very good solution for remote sensing sampling. Okay, that's just one example. Another advantage is that all subgroups represented, right? Rural areas and urban areas, they're both represented, allowing separate conclusions about each of them. Good. That's another example for the advantage of stratified sampling. It means that since I know which pixels are from rural areas, which pixels are from urban areas, so in the research, I can separate these sampled pixels and address problems separately or observe a phenomenon separately for rural areas and urban areas. That's very convenient, right? And decrease the likelihood of an unrepresentative sample. So disadvantage, difficult to identify appropriate subgroups. The example I just gave you was a simple example because rural areas and urban areas, they can be easily identified using remote sensing classification methods. But for other research studies, maybe it's hard to identify appropriate subgroups. Could be difficult. Okay, so that's a disadvantage. So next sampling method is called cluster sampling method. Sampling based on division of population geographically or organizationally. Unlike stratified sampling, grouping is for convenience, not for representativeness. Okay, which means that we divide the population into mutually exclusive and exhaustive categories or clusters. Exhaustive means that these subgroups, these categories, these clusters, they must cover all population. There should not be anyone ignored, okay? An appropriate number of categories or clusters is selected. So we divide the population into clusters, and I will just choose some clusters for sampling. And after that, you can just use all individuals within each cluster selected for your sample. Say, I will just choose cluster A and B, and I have decided that all individuals in these two clusters are observations, are picked observations for my study. Or you can do a simple random sampling method again to just sample some individuals from cluster A and cluster B, which means that I have cluster A and B, but I'm not going to use all individuals in them, right? So then two alternatives exist: all individuals within picked clusters or some of them. Okay. Advantage is very simple, right? And you don't have to do a long distance travel, and it saves resources. Okay, I divide the population into groups. I would just choose several groups, several categories, or several clusters that are convenient for me to do the sampling. Okay. Disadvantage: large error if individuals within each cluster are homogeneous, which means that if you poorly divided the population, or if you chose the inappropriate clusters for your study, the whole population could be underrepresented. Right? Like I said, I will just choose two clusters that are closer to me for the interview, for the survey. But the problem is that you decided this for your convenience. For your convenience. But can you say that these two clusters you just picked, they are representative enough for the whole population? Okay, that's a problem. That's a problem. So in the end, we have hybrid sampling, which means that we combine some of the methods I just introduced to create a more complex sampling method, right? Cluster systematic sampling, right? I set a specific interval for individuals in each cluster. Of course, before that, you need to divide the population into clusters, right? So that's cluster sampling. And I'm not going to use all individuals in those clusters I just picked. I would just use systematic sampling method within each cluster to choose some individuals for my study. So that's called cluster systematic sampling. Do cluster first, then systematic secondly. Okay. Similarly, we can have stratified systematic sampling, right? I make some strata first, use specific principles, and then within each strata, I can still do systematic sampling. Okay. So next, let me just add the spatial context to those methods, to those sampling methods I just introduced. So now we have spatial sampling. Sampling frame consists of all features located in a geographic region of interest. These features could be point features, could be lines of features, or land samples, or area features. Okay, how to apply those methods I introduced with a spatial context. The first one, simple random point sampling. Okay, could be point sampling, could be line sampling, could be polygon sampling. But let's just use point feature as an example. So we can simply select pairs of x coordinates and y coordinates at random independently. And these randomly selected points, they are not observation points, okay? They are used to define a polygon, okay? And we delete any points falling outside of the boundary of that polygon we just created, okay? Because randomly selected points, they were used to define this polygon. So there could be random points outside of this polygon, right? And the resulting pattern of points may be uneven, but that's it. For example, say we have a population and we randomly picked 4 points to form this square, which is very convenient. Let's just say this is a result. And say all points, all observation points, they are inside this square. Okay, I will just use all of them as my sample. Okay, and here is another example, right? We randomly chose 1, 2, 3, 4, 5, 6, 7, 8 points to form this irregular polygon. And unfortunately, 2 points, they are outside of the boundary of this polygon. Yeah, I will just delete them. So you can say this random process is based on the random selection of x coordinates and y coordinates, and each pair of x and y can be addressed by a point, a random point in the space. And we connect these random points to form a polygon. So that polygon was randomly created, right? And then we use the boundary of the random polygon to decide which points should be sampled. Let's just use a more precise word. Which observations or which individuals should be sampled? Which individuals or observations should be eliminated? Those within the randomly created polygon should be sampled. Those are outside of this randomly created polygon should be eliminated. In this specific example, 2 individuals, 2 red individuals, they are deleted. So this is simple random sampling method with a spatial context. Okay, so systematic point sampling with spatial context. We select 1 pair of coordinates x and y at random as starting point. Okay, now we have starting point, and this point should be an observation point or a specific individual, and locate all other points based on a distance interval. So here interval is not used to address the specific number of an individual. It is used to address an actual distance in the space. Okay, so yeah, you can start from here, from the red one, and you can assign a specific distance interval for, say, for 2 units. Then 1, 2. This is the next sample points, and 1, 2. If I'm doing this, this is not about space, because now here, let me use a pen to do this. So for example, now the sampling interval is 2 units. Okay, so from this point to the right, we have 1, 2 units. So here is another sampled points. Right. So from this point, can you say unit 1 unit, then 2 unit to this point? No, you cannot do that. To do this, because here we have a space. Distance here is Euclidean distance. The distance between this point and this point is not 2. Okay, so you can just say 1, 2. Another one is outside of this boundary. Obviously, it's not okay. But you can go to another direction. Say 1, 2. This is the next sampled points, right? So when we're talking about systematic sampling with a spatial context, the interval here is important, is distance interval, okay? Okay. So a stratified point sampling with spatial context specifies strata of the whole study area. For example, you can use this line feature to divide the space into two sub groups or two strata. And you can locate random points in each strata proportionally or disproportionately. What does it mean? It means that, for example, I just used this line feature to divide the space into a larger strata to the left and a smaller strata to the right. Because the left side strata is larger than the right one, we calculate the proportion the larger one accounts for, and the proportion of the size, of course, of the study area, the smaller accounts for. And we use that proportion to decide how many individuals should I sample in this larger strata and how many should I sample for the smaller strata. This is called proportional stratified point sampling. Well, this proportional stratified point sampling, now I think you know how to do that, right? I do not care if the strata is larger or smaller. I would just say 50% from left side, 50% from right side, right? That's disproportional because obviously the left strata accounts for more than 50% of the space of the study area, right? But I don't care, it's disproportional. Say 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 samples, 9 individuals from this larger strata, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Still 9 individuals from the smaller strata. So I don't care about this proportion anymore, okay? But of course, you would ask which one should I choose? There is no so-called correct answer here, okay? There is always a more suitable solution for your specific application or research. You may try both sometimes. When you're doing study, it's always about guessing and trying different things, okay? So you should try, okay? And the cluster point sampling, you simply divide the whole space into small subgroups for this specific example, right? We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 by 5, 25, say, cells. We have 25 cells exhausting the whole space, right? Just like a cluster sampling without spatial context, here we can choose some cells randomly and say, okay, I will just take all those individuals within selected clusters as sampled points. Of course, you can do that. Or choose some individuals from these selected clusters or cells. Again, it depends on you, depends on the people who are actually carrying out the method. So hybrid point sampling with spatial context, again, combining different methods, right? So cluster systematic, you can say that, again, this whole space is divided into small cells. And within each cell, you can say we have 4 observations sampled, right? And they are evenly distributed within each cell. Obviously, systematic method was used to make sure that a specific distance interval was applied when points or individuals was selected for sample, right? Here on the right side, we have another combination, disproportional stratified systematic, right? We have a line feature to divide the whole space into 2 strata. Strata 1 is smaller, strata 2 is larger. And it's disproportional because obviously there are more sample individuals in this smaller strata. And again, all those sampled individuals, no matter in strata, in the smaller strata or the larger strata, they are evenly distributed within space. What caused that? Of course, a specific fixed distance interval was applied to find out, to pick out all those individuals for your sampling. So that was the result of a systematic sampling method. So 2 examples for hybrid point sampling or hybrid sampling with spatial context. So in an actual study or research or in your future work, there could be more complex situations. So you need to be experienced, right? You could be a very experienced GIS analyst to find out a more appropriate and reliable solution for sampling. But do not worry about that. You always need to accumulate your experience, okay? At the beginning, when you do practice, when you do smaller project, maybe one simple sampling method will be good enough. When the situation, when the scenario gets more and more complex, you may want to just list all options of sampling methods in front of you, and maybe this one, maybe that one. What's the advantage? What's the disadvantage? If one method is not good enough, maybe I should pick 2 of them and combine them to finish my task. That's actually very complex, right? Different combinations, different probabilities, and different results, of course. So do not worry about that and start from 0. Okay, so this lecture only serves as a very beginning for sampling. Okay, thank you.